Hello students, my name is Dr.Gajendra Purohit and you are watching our YouTube channel where we upload videos for engineering, mathematics, B.Sc, or if you are preparing for any competitive exam where higher mathematics is asked, then our YouTube channel is very helpful for you. So students, 3 years ago, I uploaded a lot of videos on vector calculus where we used to have a green board, some chalk. And we used to upload content in a different way. Now I'm trying to upgrade the content. So I am uploading my content again. So students, the vector calculus series is back for you. And this time, I'm going to teach vector differentiation in this, which includes gradient, then curl, and then divergence. Condition for solenoidal, condition for rotational, plus. Vector integration includes line, surface, and volume integral. Also Green's, Stokes and Gauss divergence theorem. I'm going to bring back all these concepts. I'm going to upload this entire series one by one. So let's start. Before teaching vector calculus, I want to clear some basic concepts. It's important to understand basics. Only then we'll be able to understand topics of vector differentiation and integration properly. We studied vectors in 12th grade, so I will try to explain useful concepts that are from 12th grade and from higher levels. Students, we will talk about scalar point functions. So if we're given any function here and if I put the values of x, y, z here, for example, let's say, if I put 1, 1 or 0, 0 or 1, 2, 3 instead of x, y, z. So here, all the different points will keep coming, and what will all these points that we have will be called? They will be scalar. What do we call this? We call this scalar point function. Here, there's no ijk. So whenever we study the vector calculus, then we have the components like I, j, k. Am I right, students? It's not here, right? So what we have is the scalar point function, right? Let's discuss about what vector functions are. So if we have I, j and k components and the functions are written like this, then students, what we have here is a vector point function. If you put any value of x, y, z here, it will always be in the form of I, j, k. We'll have this in vector form. What do we call this? We call this vector point function, right? We will discuss what unit vector is. If we are given any vector, let's say students that we are given the vector I plus 2j plus 3k. Let's say that this is our vector. What is its unit vector, students? We study this in class 12, r vector upon mod of r. Students, we will get I plus 2j plus 3k divided by the value of the mod that was given here, its square. That's 1 plus its square. Plus we will do its square. So this will be I plus 2j plus 3k divided by the root 14. So what will this be, students? We get unit factor, right? The vector we have here, we write its unit factor in this way. Clear? Unit vector is vector A is called unit vector if its magnitude is 1, right? Meaning its magnitude should be 1. Now you'll ask, what does magnitude mean? Here we have coefficient of I, which is 1 by root 14. It's 2 by root 14, it's 3 by root 14. If I square all of them, right? If you look here. Students, if I write this, this will be I by root 14, right? Plus this will be 2 by root 14, right? J. Plus this will be 3 by root 14 and this will be k. So here, if this r cap is getting calculated and if I find its modulus, if I add its square plus its square plus its square, what value will we get? We will get 1. Its magnitude we will get is 1, clear? So what do we call this? This is called unit vector. We'll need this. When we'll study further, this unit vector will be used a lot. So you should have some idea about this. Moving on. There are some important remarks that I want to tell you. First thing we have here is that a vector has constant direction. If only if its unit vector is constant. I'll prove this, students. I will discuss the question later that how this works. Students, second point is that whenever we are given the two vectors, then we will see how do we calculate its dot product and cross product. You should have a little idea. Let's say we are given a vector. Vector A is given, which is 2i plus j plus 3k. And second vector given to us is 2i minus j plus 4k. If you are asked, you have to calculate A dot B, right? So what will we get here? 2i plus j plus 3k dot 2i minus j plus 4k. Students, what happens here is that whenever we calculate the dot product, we get I dot I as 1. And j dot j is also 1 and k dot k is also 1. The rest of the dot products will be 0. That means I dot j will be 0. I dot k will be 0. We need to pay attention. When we calculate I dot I, we will get 4. And students, when we calculate this, then this is 1. So here, this will be minus 1. We'll calculate this. Upon calculation, we'll get 12 and the rest will be 0. Is this clear? What will it be? 15. So students, whenever we are given two vectors, so their dot product is always scalar. Look here students, we did not get IJK, right? Now let's discuss the cross product. If we are given two vectors, so how do we calculate its cross product? For cross product, we need to pay attention here that whenever we calculate the cross product, pay attention to this point, I cross I is equal to 0. J cross J is equal to 0. K cross K is 0. We study this in class 12, right? And I cross J is K. And if you are asked that J cross I, so what will we get here? It will be minus K, right? You need to understand this, but whenever we are given two vectors, and if you want to calculate their cross product, so multiplying everything would be troublesome. The method for calculating its cross product is that we have this I, J, K, and students will put its coefficient here. Then we will get 2, 1 and 3. We'll write its coefficient here. We'll get 2, minus 1 and 4. And from this, the value of its determinant that we will achieve it will be the cross product, right? Whenever we are given two vectors and we need to calculate cross product, no need to do anything. Just write IJK. Then for given vector, it's IJK's coefficient. Second vector's IJK's coefficient, then calculate its determinant. You will get the value of its cross product, right? Now moving on, I just explained that how to calculate dot product of two vectors as well as the cross product. Now we'll discuss how to calculate a given dot product's derivative, right? Let's suppose two vectors are given, their dot product is R. How to calculate its derivative? We calculate its derivative similar to the normal process. Let's say we have T's function here. What will we get here? If it's A dot B, you have to let A remain as A. We'll differentiate B and we'll let B remain as B. We'll differentiate A just like we differentiate normally. Here it happens similarly, right? Let's discuss that if we're given two vectors here and you get its cross product. Now how to calculate its derivative? Method for calculating its derivative is almost same. It's dr by dt. Leave A differentiate B. Leave B differentiate A. The product that we'll get is cross, and what do we get here? We get dot product. Just pay attention to this. Rest of the concepts are same. Clear? Moving on. Students, this theorem is often asked in exams. Theorem states that the necessary and sufficient condition for the vector AT to have constant direction is A into dA by dt is equal to 0 if we have a vector in a constant direction. Then its value is 0, and if its value is 0, the vector we get will be in constant direction. Then what do we do? First, we assume that A is equal to alpha A cap. Actually, I want to tell you about what we know. That if we calculate the value of A cap, A vector upon P, we get mod of A, and we know students that this is a constant value, a scalar. Let's say if I take its value as alpha here, then this will be alpha and we'll cross multiply it. What will vector A be? It will be alpha A cap, right? So we will write in this way. So I assumed A like this, where the mod A will be alpha and the A cap will be unit vector. Now we need to calculate its value, right? We'll put this value instead of A, alpha A cap will be here and here. As alpha is constant, we will take it out from here. dA cap by dt and this alpha will be alpha square. So we can write like this, meaning this will be A cap into dA cap by dt into alpha square. Now moving on, we calculate its value. We'll discuss necessary condition where given that A has constant direction, so that A is constant vector. I explained a note earlier. In that note, we had this: if we have any vector with a constant direction, then that vector is always constant, right? So this A is constant, and if it's constant, then what will be its derivative's value? It will be 0. Students, we just saw that here we are getting this, and if A is constant, so dA by dt will be 0. So the value of this whole equation will be 0. Meaning if we have any vector in constant direction, then what will its value be? It will be 0. We'll prove it in reverse. If we get its value as 0, then this will be constant vector. So we'll take it in reverse. A into dA by dt is equal to 0, right? We'll put alpha A cap instead of A here, and since we put alpha A cap here, we will get this. Its value will be 0 here, and when we integrate it, then what will A cap be? Students, it will be the constant vector. And if this is constant vector, it means that it will move in constant direction, right? In this way, we can easily prove this here. Let's take some questions. We have question here if A and B are constant vectors and W is constant. And R is the vector function given by this. Here we are given A cos omega t plus B sin omega t. We are told that R into dr by dt, its value will be this, and d to r by dt square is equal to minus omega square R, right? So you will need to check that if we are given R here, if I take its derivative with respect to t, then we know that cos will be minus sine. Sine will be cos and these omega will be taken out, and so I can write it like this. What do we have here? It's dr by dt. And what do we have here? What we'll do with these two? Calculate cross product. We get value A and B here. These are constant vectors, meaning they are vectors. But what are these? Constant vector, clear? Now we'll calculate its cross product. We need to understand that whenever we calculate cross product, this A and B are constant vectors. We need to pay attention that value of A cross A, it will be 0. The value of B cross B will be 0. Whenever we calculate cross product, A cross A will be 0 and B cross B will be 0. Understand one more thing, that if I reverse this, A cross B, it will be minus B cross A. This is a relation that you need to remember. I'm calculating its value. We need to calculate R into dr by dt. What do we get as the value of R? A cos omega t plus B sine omega t, and its derivative that we will get here, students. What will its derivative be? We will get minus A omega sine omega t, and we will get B omega cos omega t, right? Now we will calculate its cross product. We know that A cross A will be 0. Now when we will multiply this with this, A cross B, and I'll write this omega here. What do we get from this cos and cos here? Cos square omega t. Now we will multiply this with this and we will get minus B cross A omega. This will be sine square omega t. And when we multiply this with this, then B cross B will be 0, right? We get A cross B here and we get B cross A here. We know that B cross A and A cross B can be changed in this way, right? Actually, this is minus, right? So we can write it in this way. What will we get here? I'll just put A cross B here, A cross B omega. This will be cos square omega t. So instead of this B cross, you can replace this with minus. A cross B, I'll take this minus to other side. We'll get this if I take minus to this side. I can write this instead. What will this be? Minus minus is plus. A cross B omega sine square omega t, right? Now you look here, students, we have A cross B. Omega is common. So students, we will get cos square omega t plus sine square omega t. We know that its value is 1. It's proved, right? So in this way, we can very easily prove this. Take a look at next question. You are told d2r by dt square is equal to minus omega square r. We can very easily prove this. We have done it once. We'll take the derivative again. So what will we get? d2r by dt square. When we take the derivative of cos, we will get minus a omega square. And here we will get cos omega t. If we take derivative of cos, we get minus sine. This will be minus b omega square sine omega t, right, students? We will take this out as common here. So minus omega square is common here. This will be a cos omega t plus b sine omega t, and what will its value be? Its value will be r. Then this will be minus omega square r. So what we will get here is the value. In this way, we can easily prove this. Now let's proceed to the next question. We are given A, B and C here, and the question has d by d theta into A cross B cross C at theta is equal to 0. You need to calculate its value at theta is equal to 0. I explained the concept to you that if we are given cross product, then how do we calculate its derivative? Ultimately, U into V concept is applied here if we discuss this. Then how we will proceed here? If I solve this, we take out A. Then we will multiply it with d by d theta of B cross C. Then what will we do here? We will do for A, that will be d by d theta cross B cross C, right? Clear? Pay attention to this. It's theta here. Is it clear? Now we'll do it again. I'll just calculate its value here. What will come here? A. And we will get cross, then I will write B here, and students, we will get dc by d theta and plus, what will I write? I will write dB by d theta, okay? Cross C and plus. Here we will be getting this as dA by d theta cross B cross C. And when you will multiply this A cross inside, then I will write the final value that we will get as. The final value here is A cross B cross dC by d theta. Plus this will go in, then it will be A cross dB by d theta cross C, and plus this will be dA by d theta cross B cross C. So what will we get here? When we expand this using this concept, then the value we get is this, right? Now we need dC by d theta, dB by d theta and dA by d theta at theta equals to 0. Let's do one thing, calculate value of theta equals to 0. Okay, I'll change the color. Then I will calculate the value of dA by d theta. So we will get cos theta multiplied by I, and this will be minus sin theta j, and we will get this as k. Cos theta will be 1. Now put theta is equal to 0, right? Because we have to put the value of theta as 0 here. dA by d theta at theta is equal to 0. So we will get this as cos 0 is 1. Sine 0 will be 0. So we will get its value from here. We need this dB by d theta in same way. So students, we have this b here. I'll do one thing, I'll calculate dB by d theta, right? If we calculate this, then the cos will be minus sine theta I, right? And this is sine here. And so this will be minus cos theta j, this is constant. So it will be 0. Now what will we do here in this? dB by d theta at theta is equal to 0. This sine 0 will be 0. What will be the value of this here? It will be minus j. Now we'll next calculate dC by d theta. Since there is no theta here, this will be 0. What will be dC by d theta here? 0. So what will we get for this entire expression? It will be 0. Now what do? We'll put all of its value, right? Let's do one thing, I'll put all of its value. Observe that this is 0. Now I will write again A cross dB by d theta into C plus this will be dA by d theta cross B cross C, right? We'll calculate this value. We'll put the values of all these here. When you put the value of A at theta equals to 0, sine 0 is 0, cos 0 is 1 and this theta is 0. So we will get J here, right? What will be A's value here? It will be J cross dB by d theta. We just calculated dB by d theta and the value of dB by d theta is minus J. Therefore this will be minus J cross C. We'll calculate the value of C here. And what is C here, students? The value of C that we are getting here is 2i plus 3j, then minus k plus dA by d theta. The value of dA by d theta is I plus k. So we will get this as I plus k. Cross B, the value of B we have is, we just put theta's value as 0. So we will get I minus 3k. What will we get? We will get I minus 3k. We'll calculate C's value here. What will be the value of C? No need to calculate C's value. It's already given. This will be the value that we'll get. I want to explain that. We'll calculate its value first. Getting my point? Focus here. We will calculate its value first, right? Pay attention here. Whenever you observe this A goes in later, we'll deal with this first, then we'll multiply this A. Understand this. We often make mistakes here. First calculate the value of this and then we need to do this, right? Whatever we have here, we will deal with this first. This will be J, cross we multiply minus J with this. Then for J into I, we have minus K, if you notice. Then J cross I is minus K. This is minus K and minus is already there. So this will be 2K, right? This J cross J will be 0. Minus is plus, J cross K will be I, right? We will get this value clear. Now we'll calculate the value of the cross product of these two. This will be I plus K. It's cross product of I minus 3K and this. The cross product of this will be, let me show you this here. How will we calculate its cross product? We'll create its matrix first. I will create its matrix here. This will be I, J and K and this will be 1. 0 minus 3, right? I's coefficient, J is 0, K's coefficient is minus 3 and look at this. This will be 2, 3 and then minus 1, right? And when you will calculate the value of this, then what will we get? We will get minus 0. Then this will be plus 9 and minus J. After that we get minus 1 plus 6. And plus K, this will be 3. When you observe this, it will be 9i and minus 5j and we get plus 3k. Then we will put this value here, right? Then I will write cross. What value do we get here? 9i minus 5j plus 3k. Actually, we calculated B cross here. We put the value of theta as 0 later. Now we are getting this answer. Moving on to the next, okay? What will we do from here? We will calculate cross product with J. If we multiply this with J, then J cross K. What do we get from J cross K? We get I. Then this will be 2i, right? And J cross I, so this will be minus K, right? We need to pay attention here. I cross J is K. K cross I is minus J. Minus K, right? We need to pay attention, clear? Moving forward, let's calculate its product. We will make matrix here. What will we do? I, J and K. What is its coefficient? It's 1. 0 and 1, right? What is its coefficient? It is 9 minus 5 and 3. Calculate its value again. Students, this will be 0 and then this will be plus 5 minus J. We will get this as 3 minus 9, right? Plus K. And this will be minus 5. When we will simplify this, then this will be 5i plus 6j. And then we will get minus 5k. Put this value here. What do we get then? 5i and plus 6j and minus 5k. So we will simplify this. What do we get from 2i and 5i? We get 7i. And then we get plus 6j and minus 6k, right? What do we get here is the answer. We can easily solve this question in this way. Okay? We'll solve this question in same way. Whole method is explained. These are all the values. We'll calculate their values at theta is equal to 0. Then we will solve it here. Thus, as you can see, we will get its answer. So, in this way, you can solve this question very easily. Thank you so much for watching. How did you like the video? Please comment and let me know. My old playlist on vector calculus is here. You can check it out. I uploaded very good videos. I am revamping my content once again in a different and new way. I'm informing you so that you get new and varied content. If you're preparing for CSIR, NetGate or IIT-JAM exams and want to improve your short tricks, you can check out my playlist here. You can subscribe my channel. Thank you very much to all of you. Bye bye everyone.